So we have a cylindrical tank, has a radius of 5 meters and a height of 9 meters. Water is draining out of it at a rate of 5 meters cubed per minute. Determine the rate at which the surface level of the water is falling as an exact value and then as a rounded value to the nearest hundredth. So pretty much always we want to make a little sketch. So let's make a cylinder. Which is just 2 ovals and then connect the sides. Okay, so let's label in what we know here. So it told us that the radius is 5 meters. Do that a little different. Okay. What else do we know? We know the height of this cylinder is 9. So that's the height of the cylinder. And now we want to figure out how fast the water is draining out of this thing, right? So inside this, right, it started at the top, and then as time goes by, the height from here to here is going to be decreasing, right? It's going to be like losing water over time. Okay, so what do we know? So we know the radius. The radius is 5. And I just want to put a little star there. It's not changing, right? Because even as this thing goes down, it's not going to be changing over time. Okay, so that's a constant. I can throw that in whenever I want. Okay, what else do we know? We know, what was this number? 5 meters cubed per minute.
That's also a constant.
Yeah, it will be. It's a rate of change.
It's a constant rate.
Yeah, it's the volume. Yeah, and it is a constant rate. It's gonna be like changing constantly over time, or it's gonna be happening consistently over time, right? And yeah, what would we call this in Leibniz notation? This would be dV over dt. Yeah, dV over dt, right? The rate of change of the volume over time. Okay, so what is that? That's going to be, this might be mind reading at this point. Think back to physics 20. This one always caught people. Remember when you were falling and the distance was negative? Direction. Yeah. Yeah, so this is going to be negative 5, right? It's decreasing, right? It started out at 9 and now it's going down and down from there. Or it didn't start at 9, sorry, the rate. Yeah, anyway. The meters cubed is going down every minute. Okay, so we're good with that one. And then we're looking for, well, what are we looking for? Determine the rate at which the surface level of the water is falling. What would that be?
How fast the blue H is shrinking.
Yeah, and in Leibniz notation, what would that look like? That would be dH dt. Yeah, perfect. That's what we're looking for.
What would the time be a problem? Because it's 5 meters cubed per minute.
No, that's okay. Time's just measured in minutes. Yeah.
So you just have to make sure you put.
Yeah, I'm not gonna usually be that mean to you and make you like convert units a bunch. So, yeah, it's more of a physics thing. Okay, so formula for this. So our formula is going to be volume is equal to pi r squared, right? The area of the circle on the bottom times height. Okay, I got a problem here. I got 3. Like if I take the derivative of this, it's gonna be an issue. Well, one thing I'd have to do like the product rule here, right? Because I got those 2, and I have chain rule and stuff involved. Any way I can make this simpler?
You take the pi out and come.
Yeah, you can take the pi out. We can actually make it even a little bit simpler.
Take the r out as well since it's constant.
Yeah, it is a constant, right? We can throw that number in, right? Because 5 wasn't changing. It's always 5. So let's just throw that in right now. So let's get the equation as simple as we can before we take the derivative. So v is equal to pi times 5 squared times h. Okay, and then we'll just write that one more time. Oop. So v is equal to 25 pi times h. So there you go. Now I just have two, right? I've just got the volume, I've just got the height. I can relate these things a lot easier, right? So, okay, I think we're ready. Let's take the derivative. So the derivative of v is dv dt. This 25 just kind of gets pulled out, right? I don't have to worry about taking the derivative of that. So it's just 25 pi. And then the derivative of h is dh dt. Perfect. Those are some of the things I know, right? So we're looking for this, right? We're looking for the how fast is the height changing, and we have the how fast the rate of change for the volume, right? So let's just plug it in now. So this is just -5 is equal to 25 pi times dh dt. So dh dt is just equal to -1/5 pi meters per minute. Okay, and then, yeah, so what this really means then, right, is that the surface level is falling at 1 meter per minute, or 1/5 pi meters every minute. Yeah, and this is just to get like a approximation on that, right? This is the same thing as -0.06 meters per minute. Gives you a bit more of an intuitive sense how fast that actually is, right?